Good day, sir. I am Rizabelle Auza from PSRD 2A, and today I will be going to discuss with you the chapter 3 entitled Electromagnetic Energy. Electromagnetic energy is a term used to describe all the different kinds of energy released into space by stars such as the sun. So these kinds of energies include some that you will recognize and some that you will sound strange. That will sound strange rather. They include radio waves. So furthermore, electromagnetic energy is present everywhere and exists over a wide energy range. So there are three examples of electromagnetic energy. So first, we have X-rays, second is we have visible light, and third, we have radio frequency. Thus, the conclusion is that electromagnetic energy have also properties, namely frequency, wavelength, velocity, and amplitude. So to begin with this topic, I will be going to discuss the visible light, the radio frequency or RF, and the ionizing radiation. Highlight these properties and the importance of electromagnetic energy in medical imaging. So in the first instance, the first topic that I will be going to talk about is all about photons. So photons is a particle that represent a quantum of light and other electromagnetic radiation. So a photon can carry energy proportional to the radiation frequency that has also zero mass. So photons have many branches. So this includes our topic, which is the electromagnetic energy. So additionally, photons is also called an atom of light. So before I end this topic, let me first state the meaning of quantum and the X-ray photon that is also include of this topic. So first, quantum can travel through space at the speed of light, while X-ray photon is a quantum of electromagnetic energy. Next topic that I will be going to discuss is all about velocity and amplitude. So velocity is the speed of something in a given direction, while is the maximum extent of vibration and measured from the position of equilibrium. So photons have no mass, therefore no identifiable form. They do have electric and magnetic fields that are continuously changing in a sinusoidal fashion. So we have this formula: 3 times 10 raised to the power of 8 meter per second. So this is what we called a velocity of electromagnetic radiation. Next topic that I will be going to discuss is all about frequency and wavelength. So frequency is the rate at which the vibration occurs that constitute a wave, either in a material as in sound waves or an electromagnetic field. So radio wave and light is usually measured per second. Next, we have the wavelength. So it is the distance between the successive crests of wave, especially points in a sound wave or electromagnetic wave. So the important properties of this mode are the frequency or F and the wavelength or the Greek letter of lambda. So next, we have the sine waves. So sine waves associated with many naturally occurring phenomena in addition to the electromagnetic energy, which is our topic. So moreover, there are three wave parameters, namely velocity, frequency, and wavelength. So that is needed to describe electromagnetic energy. So these parameters is very important in our chapter, which is the electromagnetic energy. So at the given velocity, wavelength, and frequency are inversely proportional. So a simple mathematical formula, so the wave equation is this one: V is equals to F times W, while the electromagnetic wave equation is this one. So we will move out to the electromagnetic spectrum. So, electromagnetic spectrum includes the entire range of electromagnetic energy, while diagnostic ultrasound is not a part of the electromagnetic spectrum. So, hence, the energy of a photon is directly proportional to its frequency. So, moreover, the only difference between X-ray and gamma rays is their origin. So, X-rays are produced outside the nucleus of excited atoms, while the gamma rays are produced inside the nucleus of radioactive atoms. So, based on my understanding, visible light is identified by wavelength. So, next, we have the radio frequency is identified by frequency. And lastly, the X-ray is identified by energy. So, X-rays behave as they are particles. So, next topic will be the wave model visible light. So, visible light behaved like a wave. So, nevertheless, electromagnetic energy attenuation is a reduction in the intensity that is result from the scattering and the absorption. So, last topic that I will be going to discuss with you is all about the inverse square law. So, based on my understanding, and research also, so in science, an inverse square law is any scientific law stating that a specified physical quantity is inversely proportional to the source of the distance from the source of that physical quantity. So, inverse square law has also formula. So, this is the inverse law for formula. I1 is over to I2 is equals to D1 over D2 raised to the power of 2, where I is the intensity at the distance D1 here from the source, and I2 here is the intensity of the distance 2 from the source. So that would be all. Thank you and have a great day.